Hey everyone, I just want to welcome you to these Chapter 4 videos on solving linear systems of equations. This is meant to take a look at the textbook and bring the textbook to life. You can use the textbook if you would like to review as well in conjunction along with this video, but technically this video is going to reflect what I'm expecting you to know and to understand regarding sections 4.1, 4.2, and 4.3. So I hope you find these things beneficial. So make sure that you take your notes. This is the lecture. When we come into class, we'll be doing some other things. So this is the lecture. This is the time for you to learn. There while you're at home in the privacy of your own place. Feel free to stop and rewind. If you need, be sure to pause the video, write notes to self if you would like. This would be an excellent time to do that. So outside of that, let's go ahead and get started on section 4.1. The next video set will be on section 4.2, which will cover the substitution method. And the last video in the series will cover, they call it the addition method. Traditionally, it's called the elimination method. Okay, so these should not take you, these should not be very long. I hope. I don't know. We'll find out. But anyways, again, make sure you take your notes and feel free to pause and rewind the video. All right, let's go ahead and get started now. When solving linear systems of equations, the point is to find an x and to find a y value that will simultaneously solve both the linear equations. So for example, given here we have x plus y equals 4, and we have 3x plus 5y equals 18. So the question is, what value of x and what value of y, if any, will simultaneously solve both of these equations? So our goal is to come up with techniques and methods to see if such x and y do exist, or if there's more than one x or y, or if they don't exist. So in each one of these videos, we will be talking about methods of solving along with the geometry of the lines. So in this case, what we'd like to do is to check and see, given these 2 points, 1, 3, and 3, 1, if when I substitute these back in, if they will solve these two equations. So for the first one, we have the point 1, 3. So let's just note, if I substitute into the first equation, the x plus y equals 4, so in this case, then I get 1 plus 3 here is equal to 4, and notice that 4 is equal to 4, so that one works. And then if I substitute the 1, 3 into the second equation, then I get 3 times 1 plus 5 times 3. And the question is does that equal 18? So notice that 3 times 1 is 3, and 5 times 3 is 15. And so notice that we want to know if that's equal to 18, and notice that 18 does equal 18. So notice that the point 3, 1, 3 does work, so we'll just come over here in our MyMathLab, we'll check and notice that we got that one right. So now that we're being asked, does the other point satisfy both of these equations? So let's just note, if we substitute, I get 3 plus 1 equals 4. That's the question. And here we have 4 equals 4. So that checks out. So let's just note that if I substitute into the other equation, okay, so we get 3 times 3 plus 5 times 1. And we want to know, does that equal to 18? So notice we get 9 plus 5 equals 18. So here we get 14 equals 18. And notice that doesn't work. So again, we'll just come over here to our MyLabs and we'll just check no. And we'll just come over here and notice that we got it right. Okay. So again, what we'd like to do is to validate whether a given x and y, or given an x value, find a y value, etc., and so forth, satisfies these equations. The method of solving a linear system of equations is called the graphing method. To be honest with you, the graphing method is not the preferred method, but it is a method, and this method will help us to understand the geometry of the lines. So here we have that x plus y equals 9, and here we have that x minus y equals 1. So both of these equations are in the standard form. And one of the things we can do with the standard form for the equation of a line is to find the x and y intercepts. So let's just note that x plus y equals 9. So what I can do is just come over here, and notice I can get some ordered pairs here. And recall that we just have to set one of these equal to 0 and solve. So notice that when I set x equal to 0, I substitute here, so we get 0 plus y equals 9, which means that y equals 9. So notice I can plug that into there. And now when I substitute 0 in for y, I get x plus 0 is 9. So x equals 9. So here I get 9. So for my first equation, we have the points 0, 9, and 9, 0. So let's take a look at our second equation. So x minus y equals 1. And again, we can do the same thing. So here I come up with my ordered pairs. And I'll just use the y-intercept form. Okay, so again, substituting, I get 0 minus y equals 1. So minus y equals 1. And so technically, to turn the y to a positive, you can either think of this as multiplying or dividing by -1. So let's just recall that a negative divided by a negative is negative, and so forth. So here we get a positive y on this side is equal to -1. So here I can go ahead and plug in a -1, and then we get x minus 0 equals 1 when I substitute this y into here. So now we get x equals 1. Okay, so now we have our sets of ordered pairs. So now all we have to do is come over here, and to assist you along the way, if you will, this button right here will pop out and kind of make this a little nicer for us to see. Okay, so then here's our line tool here. So again, if you notice up over here, this part here will tell us where we're at on the XY system. So again, if we come over here, 0 up to 9, so that puts us here. Okay. And then we have to go over 9, 0. Okay, so notice my coordinate there is there, so I just do that. So there's my first line. Okay, so then I'll come over here, and now we'll use our graphing tool again. So go over 0, and then down -1. So there's that point. And then come over here to 1, 0. And there's that point. Okay. So notice here we have the two lines, and we have that these two lines intersect right there. So that's going to be our next goal. So let's go ahead, when you do the pop out, click to save. Okay, so we've got our graph. So we'll just go ahead and check the answer here. All right, so we got it right. Yay us. Okay, so now we got to come over here and identify the solution. So again, we'll just pop this out here. So now we just have to come up with the x and y for this intersection right here. So we can easily see here that the x value here looks like 5. So I'm going to come over here and write that down. So here we get 5. And then we'll come up over here to our point, project back here. It looks like 4. 5, 4. Okay. So before I go over and do any check, let's just note that if I come back over here to my original equations and substitute, notice that 5 plus 4 equals 9, so we get 9 equals 9, so that checks. And then if I come over here to my second equation, let's just note that we get 5 minus 4 equals 1, and 1 equals 1, so that checks. So we'll just close that out, and so we know that our ordered pair, so notice it says to type as an ordered pair, so you can either type in a parenthesis or just come over here and click here. All right, so we'll just type in a 5, and then arrow over and a 4. Oops. Make sure we get it in the box. Here we go, 5, 4, and then check answer. All right, so we got it. So that's it. All right, so here we're given this linear system of equations. So here we have y equals 4x, and here we have 4x plus y equals 8. So in this case, what we'd like to do is to solve by graphing. So again, we'll just come over here, and let's just note that since this is in the slope-intercept form, there's a couple of ways we can do this to come up with our 2 points. That is, one, you can choose 2 different x values, or you can use the fact that the y-intercept is 0 and then go up 4 and over 1. I think in this case, I'm just going to choose some values here. So let's just note, since it's in the form y equals 4x, I'm just going to choose 2 different x values. You can review the summary of graphing that I have posted as well on how to handle these. So I'm just going to choose 2 different x values. So I'm going to choose wisely on my x values. And when I say choose wisely, I'm going to choose the things that's going to be the easiest for me to compute. So I'm just going to compute an x equals 0 and an x equals 1. So notice that when I substitute 0 in, I get y equals 4 times 0, which is equal to 0. So I get 0, 0. And notice that when I substitute a 1 in, I get y equals 4 times 1 equals 4. So there's my 2 points for the first equation. And in the second equation, again, I have this in standard form. So I can go ahead and choose the x and y intercepts. So I'm just going to write these down like this. So I'll make my substitution here. So I get 4 times 0 plus y equals 8. So y equals 8. So I'll just put an 8 there. And then I'll substitute here. So we get 4x plus 0 equals 8. So 4x equals 8. So x equals 2 when I divide both sides by 2. So then I'll put a 2 right there. Okay, so I got my first 2 points here for the first line, and then I got that for the second line. All right. So I'm going to come back over here. So again, let's make this a little bigger. So here we got 0, 0. So we'll start here. And then we got the point 1, 4. So we'll go there. Okay. And now we have, let's see, the point 0, 8. So 0, 8. And then the point 2, 0. Okay. So there we go. We'll save that. Check our answer. Okay. Nice to know we got the graph right. So again, we just come back over here and find the intersection, and it looks like we've got, at this point, x is going to be 1 and y is going to be 4. So 1 comma 4. Okay. So again, we can check these out by going to our equations, and notice that when x is 1, y is 4. And again, we get 4 plus 4 equals 8, so that works out. So we'll just come over here. We'll click here, and I'm just going to do an open bracket, 1 comma 4, type them in like that. Check my answer. Ta-da! Okay, all right, so that's graphing equations when the lines intersect. So let's take a look at a different instance. So here we're given this linear system of equations that x plus y equals 5 and x plus y equals negative 5. So again, we want to solve this using a graphical approach. So let's just note that since it's in standard form, we'll just come up with our 0, 0. And for the second line, we'll just 0, 0. Put a comma right there. So let's just note that for the first equation, we have x plus y equals 5. So when I substitute 0 plus y equals 5, so y equals 5. So I'll put a 5 there. And let's just note that when I substitute the y as 0, so I get x plus 0 equals 5, so x equals 5. And then when I come over here for my second line, so we get x plus y equals negative 5. So again, 0 plus y equals negative 5, so y equals negative 5. So I'll put a negative 5 right here. And then we get x plus 0 equals negative 5. So x equals negative 5. So I'll put a negative 5 here. All right. So now let's come over here and let's check our graph. So here we get 0, 5, and 5, 0. So 0, 5, and 5, 0. And then for the next one, we get 0, negative 5, and then negative 5, 0. So we get that line. Okay. So as we can take a look here, these two lines appear to be parallel lines. All right. So let's just note that parallel lines will never intersect. All right, so parallel lines will never intersect. Consequently, since the two lines do not intersect, we have the fact that there would not be any solution to this equation. Okay, so we can see that our lines are parallel. We have the correct lines. Since the lines are parallel, that means there is no solution because the lines do not intersect. So here we just come over here and we will check no solution. Okay, and notice that we got that correct. So let's come back over here and let's just note that parallel lines will have same slope, different y-intercepts. So let's just note that x plus y equals 5, so y equals negative x plus 5. That's my first line. And taking my second line and putting it into slope-intercept form, I get x plus y equals negative 5, so y equals negative x minus 5. So let's just note that here we have, basically in front of this x, we have a slope of negative 1. Okay? So notice they have same slope, but let's just observe that we have a y-intercept here of 5 and a y-intercept here of negative 5. And again, coming over here to our graph, we can easily see that there's the y-intercept of 5 and there's the y-intercept of negative 5. So the moral of the story is this: when you go to graph and you have two parallel lines, that means that the two lines have the same slope. That means that there's not going to be a solution. So we just come back and say no solution. Okay, so for this one, when we want to take a look at our x and y intercepts, notice that when I substitute x as 0, I get y plus 3 times 0 equals negative 3. So y equals negative 3 because this goes to 0. So I can put a negative 3 right here. Now substituting 0, so I get 9x plus 3 times 0 equals negative 9. So 9x plus 0 equals negative 9. So 9x equals negative 9. So x equals negative 1. So I could put a negative 1 right here. Okay. Try again. All right, so to solve this one, let's find the x and y intercepts. So I get 0, comma 0. So I get, for x is 0, I get y plus 3 times 0 equals negative 3. So y plus 0 equals negative 3. So y equals negative 3. So I'll plug a negative 3 there. And now I get y plus, so when y is 0, When y is 0, I get 0 plus 3x equals negative 3. So 3x equals negative 3. So now divide by 3. So I get x equals negative 1. All right, so now I come over here and I get a negative 1. Now working with our second line, let's just again try our intercepts. So notice when x is 0, I get 9 times 0 plus 3y equals negative 9. So 0 plus 3y equals negative 9. So 3y equals negative 9. So y equals negative 3. So I divide both sides by 3. So notice here I put a negative 3 here. And then doing the other one, I get 9x plus 3 times 0 equals negative 9. So 9x plus 0 equals negative 9. So 9x equals negative 9. So divide both sides by 9. So I get 9. So I get x equals negative 1. So notice here we get negative 1. So if we stop for a moment and observe our ordered pairs, notice that the ordered pairs are exactly the same. Okay, exactly the same, which means that these two lines over here, they must be the same line. So let's just observe real quick that if I take y plus 3x equals negative 3, and I solve for y, put it into slope-intercept form, notice I get y equals negative 3x minus 3. And notice if I take the 9x plus 3y equals negative 9, again, solve for y. So notice if I subtract 9x from both sides, then I'm going to get 3y equals negative 9x minus 9. And now if I divide both sides by 3, so then I get y equals negative 9 over 3x minus 9 over 3. So notice here I get y equals negative 3x minus 3. Notice that these are exactly the same equation of the line. All right, so let's just notice that if I come over here again, and so come back over here to our y-intercept, so we have 0, 3. Or, I'm sorry, 0, negative 3. So 0, negative 3. And then negative 1, 0. Go ahead and save that. Check my answer. There it is. And then when we have the exact same lines, then if we take a x and solve for x and come up with that y, that same x and that same y will solve all the systems. So here we will just check off that there are infinitely many solutions. So the moral of the story is when you have the same points, when you go to get your points over here, and these points happen to be the same, that means that the lines are the same. If the lines are the same, then you have infinite number of solutions, and that the lines are the same. All right, so let's go ahead and put a summary to this real quick. So I hope this video helped you out. As a method of a summary, let's just note that when you come up with your ordered pairs and you plot the lines, when the two lines intersect, at the intersection, you will have a unique solution or one solution, and it's at that point, x, y, where the two lines intersect. When you go to solve and you actually have this, a line that has the same slope, different y-intercepts, you have parallel lines. So the moral of the story here is when you have parallel lines, there is no solution. And then finally, when you go to solve these things and your ordered pairs happen to be the same, then that means that the line is the same. Okay, so you have the same line, so the solutions then become an infinite number of solutions. Okay, so we're going to see the exact same thing in the next two videos, just going to be different methods of solving. So I hope this helped you out. Thanks.